Okay, so this is the DEB Mock 2017 Paper 1 Question 10. Okay, and it reads, a triangle has three sides as follows. 3x plus 2, 2x minus 5, and x plus 1. And they show us a picture of a triangle, and you would then relate to that, okay? Calculate the length of the perimeter of the triangle in terms of x. Give your answer in its simplest form. Okay, so we have to calculate the perimeter in terms of x, okay? And in order to do that, we would know that perimeter is the sum of the three sides. So we'll take our three sides. Okay, these are our three sides. Might be an idea now to name these side 1, side 2, and side 3. Okay, we'll call them that. And what we're going to do is sum the three of them together to get the perimeter in terms of x. So 3x plus 2 plus 2x minus 5 plus x plus 1. You could wrap these all in brackets if you wanted, but there's no real need to at the moment. So 3x, and what we'll do is add the like terms being the x's and then the numbers. So 3x plus 2x is 5x, plus another x is 6x's. 2 take away 5 is minus 3, plus a 1 is minus 2. Is that right? Yes. Okay, so this is the perimeter of, so perimeter is equal to 6x minus 2, and it's the perimeter written in terms of x. Okay, question 2 reads, or part 2 reads, show that the triangle is isosceles when x is equal to 6. Okay, so we just have to show that it's isosceles when x equals 6. Now, what is an isosceles triangle? A triangle with two sides are equal length, or two corners, two angles are equal length. Okay, so in our triangle, how do we know what the lengths are? Well, we don't, but they've just told us that x, it says when x equals 6. When x equals 6. So what I will do is I'll take this side and substitute 6 in, and so on. Okay, so let's say side 1 is equal to 3 times 6 plus the 2. So side 1 is equal to 3 sixes, which is 18, plus the 2, which is 20. Okay, side 2 is equal to this guy here, which is 2 times the x, which is now 6, plus, minus the 5. Okay, so 2 6s are 12, take away the 5 is 7. And then side 3 is going to equal a single x, which the single x in this case is 6, plus the 1, which is equal to 7. So from this, we can see that side 2 and side 3 are in fact equal to each other. Okay, so, and what was the question? The question was, show that the triangle is isosceles when x is equal to 6. Okay, so therefore isosceles. All right. Okay, next part, part 3. Mark says that x is equal to 6 is the only value of x such that the triangle is isosceles. Is he correct? And justify. So Mark is saying that this is the only case when our triangle is isosceles. Now, is he correct? So how did they find where it was isosceles? But we need to consider, well, what about side 1 and side 2? We need to consider, what if they are equal to each other? Is that not an isosceles? So we got to go and check. Now I need this space to work, so I'm just going to rub this out. Okay, so like I was saying, I got to check, are these two sides not the same? And is it not possible for those to be the same? So what you would do is you would say 3x plus 2 is equal to 2x minus 5. This is now me testing, are they the same? So what we would normally do is move all the x's to one side and the numbers to the other. 3x minus the 2x is equal to minus 5 minus the 2. So what have I done? I have moved this 2x over here, and I have moved this 2 over here to a negative 2. So this becomes 3x take away 2x, which is a single x, and minus 5 take away 2 is minus 7. Okay, so when I make those two things equal to each other, it tells me that x is equal to -7. So I will test this side. Is this side, what happens when I plug in -7 into it? 3 times -7 plus 2 is equal to what? Well, 3 times -7 is 21. It's -21. Plus the 2 is equal to something. Okay, so -21 plus the 2 is equal to -19. Okay, now this is actually equal to side 1. Side 1, all of these are side 1s. So, if I forced side 1 and side 2 to be equal to each other, and I got a value for x, I then plugged the value for x back into side 1, it's telling me that side 1 must be -19. That's an impossibility because you can't have a triangle with a side that has a negative length. Okay, so this is not a real triangle. So what do we write down beside that? Yeah, as side is less than 0, it cannot be a triangle. Okay? Now that was a test for side 1 and side 2. Once we made them equal to each other, our side 1 failed to be a side, so it can't be a triangle. Now, they did these two for us. We have just done side 1 and side 2. There is another option, which would be side 1 and side 3. So let's do that. Side 1 and side 3. What would happen if they were equal to each other? Would this not be an isosceles triangle? So we go with 3x plus 2 is equal to x plus 1. Okay, and we rearrange to find out what x is equal to, and we get 3x minus an x is equal to 1 take away a 2. And we get 3x take away an x is 2 x's. 1 take away 2 is -1. And we divide by 2 on both sides, and we get left with x is equal to -1/2. Okay? Now, when you plug -1/2 in to this, you will get an answer of 1/2, and I think it's, I'm not sure here. But if you plug it into this one, so it's a bit of a tricky question. You had to go through all three of them. But if you had just gone straight for this one, the 2x minus 5, so 2x minus 5, and what I'm going to do is substitute in the -1/2. 2 times -1/2 minus 5. Okay, 2 times -1/2 is 2 halves are 1, so it's -1, -5, and that equals -6. Okay, so -6 here is not a real side. So side 2, this is equal to side 2. Okay, because I just did that. I plugged in the -1/2 into side 2, and I found out that side 2 is -6. So as side is less than 0, it cannot be a triangle. The same reason applies why this is not a triangle. Okay, and that answers the original question. The original question is this the only case where the triangle is isosceles when x is equal to 6? And the answer is yes. Yes, this is the only case that the triangle is isosceles when x equal to 6, because if the other two triangles, if you make side 1 and side 2 equal to each other, we get a false triangle, a triangle with a negative side in it. And if we make side 3 and side 1 equal to each other, we get a triangle with -6 on the side 2, which again isn't a possible triangle. Okay, so that's your justification. Tricky little question. Okay, again, any questions, put them in the chat.